Okay, so this is lesson 1 for unit 4. We're going to describe and graph situations. So for 4.1, we have the bagel shop. So we have 1 bagel is $1.25, 6 bagels is $6, 9 bagels is $8, and 12 bagels is $10. A customer at a bagel shop is buying 13 bagels. The shopkeeper says that would be $16.25. Jada, Priya, and Han, who are in the shop, all think this is a mistake. So Jada says to her friends, shouldn't the total be $13.25? Priya says, I think it should be $13. And Han says, no, I think it should be $11.25. Explain how the shopkeeper, Jada, Priya, and Han could all be right. So here's what we're going to do. You guys only have this one column right here. So I'm going to make this column right here be the cheapest, or the cheapest cost. We'll put it, just the cheapest total cost. Let me change that to be cheapest total cost. So, first thing, let's see here. Let's see how much it would cost for... Let's start with the shopkeeper. If we have 1 bagel, that's $1.25. So I'm going to put shopkeeper here. Oops, keeper. And we are going to... All right, so for the shopkeeper, 1 bagel is going to be $1.25. 2 bagels is going to be $2.50. 3 bagels is going to be $3.75. 4 bagels is going to be $5. 5 bagels. So we're just adding down. We're adding all the way down to 13. So $5 plus $1.25 is going to be $6.25. $6.25 plus $1.25 is $7.50. $7.50 plus $1.25 is $8.75. And then let's see here. So now I'm just going to say 8 is going to be $10. 9 is going to be $11.25. 10 is going to be $12.50. 11 is going to be $13.75. 12 is going to be, let's say, 15. And lastly, 13 is going to be $16.25. So that's how the shopkeeper got his cost. So now let's look at Jada. Jada says to her friends that shouldn't the total be $13.25. So let's see how Jada got her cost. Let's see here. So if we take 6 bagels, and it's $6. What is 12 bagels? So 6 and 12, so we know that 6 times 2 is 12. So we're just going to multiply this amount right here by 2. So we will get $12 here. Then we're going to add the cost of 1 bagel to that $12. So it's going to be $13.25. And I'm going to go ahead and fill in the numbers in between here. So we're going to have $7.25, $8.50, $9.75, $11, and $12.25. All right, now we're going to look at Priya and see how she got $13. So we're going to start with 9 bagels is $8. So we're going to go over here and say $8. And this one is Priya. And then we are going to add $1.25 to $8. So we're going to have $9.25. $10.50. $11.75, and then $13. And lastly, we are going to look at how Han got $11.25. So we're going to look at our 12 bagels and say it's $10 there. So we're going to have Han said $10. Then add our $1.25 to make it 13, and we're going to get $11.25. Now, here's where we're going to put our numbers into the table that's on your paper. We're going to pick the cost that is the cheapest out of all of these options. So we're going to say there's nothing here other than the shopkeeper's price, so we're going to say $1.25. Same here. So we're going to have $2.50, $3.75, then $5, and then $6.25. Then now I'm going to look between these two options. And I'm going to say $6 is less than $7.50. So I'm going to put $6 there. Same thing here, we're going to look between these two, and then $7.25 is less than $8.75. And then we're going to go to the next one, and we're going to get $8.50. Then at 9, we have to look between all 3 of these numbers, and we see that 8 is the cheapest. So we're going to put an 8 in here. Then we're going to go with the $9.25. Then we're going to go with the $10.50. And now we have another column to look at. So we're going to look between all 4 of these numbers, and we're going to see that 10 is the cheapest. So $10 and then $11.25. So depending on how we counted on this would determine which price would be correct. And they all could be, depending on how you looked at it. So if we looked at all of these prices, all 4 of these columns would not be one function, but the cheapest total cost could be a function. If we looked at just the shopkeeper, that would be a function. So we would take $1.25 and multiply it by the number of bagels. All right, let's go to the next page. So here is what the graph would look like of all of that information from the previous page. So let's see here. So the blue circle, that's going to be the shopkeeper's price. The green circle, let's see here, move that over. So the green circle is going to be, I believe that was Jada. So Jada's price. The red square is going to be Priya's price. And lastly, we have Han's price, which is the triangle, the solid triangle. Then we have this graph here, which is going to be the number of bagels. And I know you guys don't have this in your packets. This is something that was just in the teacher materials. But you can see how they determine the cheapest price per bagel here with these X's. All right, and then you guys should be on 1.2. So here we have this, again, this is just in the teacher information. So we're going to look at these days down here and determine which day this graph up here represents. So we have 3 days in a row. A dog owner tied his dog's 5-foot-long leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within minutes, not within 5 minutes. The dog's movement each day is described here. On day 1, the dog walked around the entire time while waiting for its owner. On day 2, the dog walked around for the first minute and then laid down until its owner returned. And then on day 3, the dog tried to follow its owner into the store but was stopped by the leash. Then it started walking around the post in one direction. It kept walking until its leash was completely wound up around the post. The dog stayed there until its owner returned. Each day the dog was 1.5 feet away from the post when the owner left. Each day, 60 seconds after the owner left, the dog was within 4 feet from the post. So down here, we have these 2 points that the dog always goes through. So he's 1.5 feet away from the post. If I look up here at my graph, we have the distance from the post in feet is on the y-axis. So that's going to be my y variable, so 1.5. When the owner left, that's going to tell me that's at 0 seconds. Okay? And then the second point, we have 60 seconds and 4 feet. So I'm going to say 60 is my x variable, or my x value, and 4 feet is my y value. So I can look up here at these points and I can say that this is 0, 1.5, and this one is 60. And I can verify that by looking at my graph. So I go up to 1.5 here, and over here we go up from 60, we go up to 4. Okay, so we can see our point. So this day, we can see that the dog moved quite a bit, up to 5 feet, which was our length of the leash. Then he started to go back down, and we got to our 60 seconds when he was at 4 feet. But then it just kept going down, and it never went back up again. So I can see that the dog is very close to the post at the end of the time frame we have here. So that makes me think that this graph represents day 3. Because he got super close to the post. He didn't walk around a whole lot. Other than going in a circle. All right, let's go to, let's see here. This looks more like what you guys have. It says here that I'm going to assign one of the days for you to analyze. So let's see here. If you are an A-day student, I want you to do day 1. So A-day gets day 1, and B-day gets day 2. And we will look over these together in class first thing. Then are you ready for more? So from the graph, is it possible to tell how many times the dog changed directions while walking around? And then explain your reasoning. So this graph does not tell me direction. So if the dog was walking in a circle, let's see, if you're a more visual person, let's say here's our fence post. And the dog is walking around in this direction, and he decides to stop and then turn around and go into the other direction. Did his number of feet from the post change? No. So, no. it is not possible to determine direction from distance. All right, we have one more page left to go over. So we're talking about a function. Here are two pairs of quantities from a situation you've seen in this lesson. Each pair has a relationship that can be defined as a function. So time in seconds since the dog owner left and the total number of times the dog has barked. So initially when I saw this, I did not think that this was a good option because it wasn't really what you had seen in the lesson, but I think what they're trying to pull from is the dog from the second part. And so we're gonna leave it as it is. And let's look. So this first one, I'm gonna do the first one and I want you to try to do the second one. So we're gonna choose one pair of quantities, so I'm doing the first one, and express their relationship as a function. So in this function, which variable is independent and which one is dependent? So our independent variable, independent, is time in seconds since the dog owner left. So time in seconds. I'll go ahead and put since the dog owner left. Since the dog owner left. So that means my dependent variable is the total number of times the dog has barked. Total number of times the dog has barked. So write a sentence of the form. So that's going to be, so your dependent variable is going to be a function of your independent variable. So the total number of times the dog has barked is a function of time in seconds since the dog owner left. All right, so this last part is to sketch a possible graph of the relationship on the coordinate plane. Be sure to label and indicate a scale on each axis. So we're going to say the x-axis. The x-axis is our independent variable, so time in seconds. Then we're going to use, let's see here, number of barks, total number of barks. Total number of barks on my y-axis because it is our dependent variable. So let's see here. What was our scale on that last one? So we're going to do by 20s. So 20, 40, 60, 80, 100, 120, 140, and 160. Let's see here. Let's do... So we don't actually know a ton about the situation, so what I'm going to do is I'm going to say, let's say bark 2, 4, 6, 8, 10 times. We could do anything we wanted for this. We could say the dog barked. He probably barked a couple times here at the beginning, right? Because his owner was walking away. Do your dogs do that? Mine does. Then maybe every once in a while, maybe a squirrel ran by. So we have 3. And we could just go up. This would not go down because it's the total number. So we could connect this however we want to. All right, so make sure you attempt to do this one right here. And also remember to do, on this back page, do the A day do day 1 of your A day, do day 2 of your B day. All right, I'll see you in class.